Welcome, A2I students. This is Mr. Sierra from Poly High School. Just going over the getting started for Unit 3. A couple of things that will help you out in this unit and a couple of things as review from Unit 2. So let's go ahead and begin. First one here is to draw a graph to show how the figure is transformed by the function, then classify the transformation as rigid or non-rigid. So I look at the notation here and determine that this is a translation. And it tells me to take the x values, subtract 2, so that's going to cause it to move 2 units to the left. And then take each y value and add 1, which is going to cause each vertex to move 1 up. So I'm going to look at each vertex here. I have these little circles here at each vertex. And I'm going to take each one. I'm going to move it 2 to the left, 1, 2, and 1 up. That one goes there. Take this one, move it 2 to the left, 1, 2, and up 1. There we go. And I'm going to move this one 2 to the left, and up 1. And finally, the last one, 2 to the left, and up 1. And so I'm going to go ahead and make my rectangle again around these parts. Looks like this. Since my rectangle has the same shape, the same size, I'm going to say that this is a rigid transformation. Okay. Look at number 2. In number 2 here, I look at my notation. It says take each x value and multiply by 0.5. Take each y value and multiply by 0.5. So that's what I'm going to do here. Is I take, well, first thing I did was I went ahead and I labeled the vertices so I know which ones are which. Okay, so I labeled this corner here A, this corner here B, this corner here C, and this vertex here D. So I took the vertex of A, which was 4, 3. And I took the 4 multiplied by 0.5, 3 multiplied by 0.5. And I get my new coordinates, so my A prime is going to be 2, 1.5. I do the same thing with B. Take my original coordinates, multiply by 0.5, and I get my new coordinates B prime here. The same thing with C, and the same thing with D. So you can see that these 4 here, these will be my new coordinates. So I'm going to go ahead and plot these 4. Okay, so A will be at 2, 1.5, which is about here. My A prime, my B prime is 0, 1.5, so about here. C prime stays 0, 0, doesn't move. And D prime becomes 2, 0 right here. And I go ahead and mark these, A prime, B prime, C prime, and D prime. I go ahead and make a rectangle there, as I did before. Well, you notice in this one here, since the size did change, this is a non-rigid transformation. Look at number 3. At number 3, they ask us to simplify. Now, in this unit, we're going to do a lot of this. This is going back to Algebra 1. If you need more help on simplifying radicals, square roots, you can come to one of the tutorial sessions that we have after the afternoon, and we can help you with that. All right, so if I have the square root of 72, the way I tend to do them is I make a tree of prime factors. I do a prime factorization. So what I do is I break down 72 into all prime numbers. The way I do this is I start dividing by prime numbers. So I start by dividing 72 by 2, and 72 is the same thing as 2 times 36. 2 is prime, so I leave that. But I keep going with the 36. I can make the 36 as 2 times 18. 2 is prime, 18 is not, so I break down the 18 into 2 times 9. This 2 is prime, the 9 is not again, so I break down the 9 into 3 times 3. So here I have my factor, my prime factorization. So the square root of 72 essentially becomes the square root of 2 times 2 times 2 times 3 times 3. Now, since I'm taking the square root, actually there's a little 2 here that you can't see. To simplify this, I take pairs of the same number, pairs of these prime numbers. So I do have a pair of 2s and a pair of 3s. So as I knew, 2 times 2 is 4, and the square root of 4 is 2. So that comes back outside of the square root, as well as this one here, 3 times 3, which is 9. Square root of 9 is 3. So I'll pull out a 2 and a 3 here. That comes out. That's from this 2. That's from this 2 here. And this 3 is from here. Right? Square root of 3 is, square root of 9 is 3. Square root of 4 is 2. And what's left underneath the square root is a 2. It doesn't have a pair, so it just stays under the square root. And I get my final answer here. I simplify the outside here. 2 times 3 is 6, square root of 2. Now, sometimes you'll get an answer in which you'll get a radical in the denominator here. So, and that is not proper form. So how do we eliminate a radical in the denominator? Is what I'm going to do is I'm going to multiply this times 1. But I'm going to disguise that 1 as a square root of 5 or square root of 5. And I'll show you why here in a second. So I take my original problem here. And as I said, all I'm doing is I'm multiplying it times 1. Remember, square root of 5 divided by square root of 5 is 1. And when you multiply by 1, it doesn't change the value. So I'm just using this to be able to get rid of the square root of 5. The reason I can do that, get rid of that square root of 5, is because on the bottom now, denominator here, I'll have square root of 5 times square root of 5, which is square root of 25. On the top, 7 times square root of 5. And as you know, the square root of 25 is 5. So now I no longer have a radical in the denominator. I have 7 square root of 5 over 5. That's our simplification. Again, if you need more practice on these, you can look it up on the internet or you can come to one of our tutorial sessions. Here we go, solving for x, a little bit of review from Algebra 1. Here in this case here, the first one here, in order to solve for x, I want to multiply both sides by x so I can get it in the numerator. And then my x's here will cancel out. So I'm left with 5x, rewrite the order here. 5x equals 2. Now divide both sides by 5. Again, my 5's cancel out, so I get that x is equal to 2 over 5. Look at letter B. This is a quadratic. Different ways to solve it. You can use quadratic formula. I like to go ahead for this one. It's a trinomial. I like to see if it's factorable, so I'm going to go ahead and factor it. Okay, so in factoring a trinomial, I'm looking for two numbers. When I multiply them, gives me 2, and when I add them, it's going to give me 3. Here. So in this case here, it's going to be, factors are going to be x plus 2 and x plus 1. Again, still equal to 0. And now I'm going to set each one of those factors equal to 0, and I'll get my two answers here. So x plus 2 equals 0, and x plus 1 equals 0. And solve for x. I subtract 2 from each side. Minus 2 on this one, minus 2. 0 minus 2 is negative 2 on the other one. Here I'm going to subtract 1, minus 1, minus 1. X equals negative 1. So those are my two values of x, my two answers. And finally, the last one here, solving for x. I want to get rid of this denominator here. So I'm going to multiply both sides times the square root of 14. As you can see here, the square root of 14, the square root of 14 is on the right side. They will cancel out. On the other side, I get 14, square root of 14 times square root of 2, which is square root of 28, over square root of 7. And square root of 28 divided by square root of 7 is square root of 4. Remember that you could always write this as follows here if you wanted to. You could write these as, square root of 28 over 4, over 7. Excuse me. So 28 over 7 is 4. And the square root of 4 is 2. Okay. Look at the next one. Find the distance between those 2 points, 3, 5, and 7, negative 1. So I'm going to go ahead and use the distance formula that's on your formula sheet. This was going back to Unit 1. And the first thing I want to do is plug in, label the points. So I label my first point, 3, 5, I'll label those as x1 and y1. The second point is 7, negative 1. So I'll label those as x sub 2 and y sub 2. And technically, I could switch this. I could call this the second point and this the first point. Doesn't matter which one's which. Just keep the x's in order and the y's in order. I plug it into my formula there. And I simplify everything under the square root. I don't want to plug it into all my calculator because in this unit here, we want to simplify the radical and not get a decimal that goes on forever. So here I'm going to get underneath the radical, I get 52. And how do I simplify that? That becomes 2 square root of 13. Quick example on how to simplify the square root of 52. Again, I'm going to do a prime factorization. So if I have square root of 52, I'm going to separate that as to 2 times 26, which breaks down to 2 times 13, which gives me the square root of 2 times 13. Here I have a pair of 2's. That's going to come out. And what's left under the square root is 13. So 2 square root of 13. That is my distance between the 2 points, simplified. Number 5 here again, going back to Unit 1. Find the lengths of AB and BD. If AD is 29 units, so I'm going to move this down. So I can say that AB plus BC plus CD equals 29. And all I'm going to do is substitute the expressions into each part. AB is 2x plus 4, BC is 2x, and CD is x. I'll put that in. Take off the parentheses there because there's nothing to distribute. Then I combine my x's. I have 5 x's. So 5x plus 4 equals 29. Then I'm going to subtract each side by 4. Which gives me 25. And then I divide each side by 5. and I get that x equals 5. Now, what we want to do is we want to find the lengths of AB and BD, so that gives us x. So in order to find the lengths, though, I got to plug it in. So to find AB is 2x plus 4. I replace the x with the value of x, which is 5. So 2 times 5 plus 4 is 14. And same thing with BD over here. BD is BC plus CD, so which is 2x plus x, which gives me 3x. X is 5. Plug it in, and I get BD is 15. Solve the following equation for A. So here, if you follow step by step, the first thing I want to do is multiply both sides times C to eliminate that denominator. Remember, I'm trying to isolate the A, so I want to get rid of everything on that left side that I can. So multiply both sides by C. My C's will cancel out on that side. On the right side, I get DC. So I have 2A plus B equals DC. So now I eliminate my B. So I subtract B from both sides. Now I want to get rid of that 2, that coefficient. So I divide both sides by 2. Remember, you can divide all of it by 2, not just the DC or the B. And I get that A is equal to DC minus B all over 2. Next one here, evaluate this. So in evaluating this, what I'm going to do is first I'm going to distribute. Well, the first thing I did was simplify square root of 36, which gives me 6. Now I'm going to distribute this 2. So that 2 times 6 is 12. And 2 times 2 square root of 2 is 4 square root of 2. You don't really need that line there. So I have 4 square root of 2 plus 12 minus 4 square root of 2. So I have 4 square root of 2 minus 4 square root of 2. Those two will cancel out, and I'm left with just 12. Find the lengths of side A in the right triangle. So since they tell us this is the right triangle, now we can assume that this will be the right angle here. So I can just use the Pythagorean theorem, a squared plus b squared equals c squared. Plug in, I know a is a, b is 3, c is 7, the longest side. Plug it into my formula here, follow step by step. A squared is 40. Now, one thing that's different here is that you want to simplify this after I take the square root. So in order to simplify square root of 40, here I take 40, same thing as 2 times 20. 20 is 2 times 10, and 10 is 2 times 5. So put all those on there. So square root of 40 is the same thing as the square root of 2 times 2 times 2 times 5. And again, I want to take pairs because this is a square root. If this was cube root, I would take groups of 3. This is a square root, so I'm going to take pairs of 2. So here I have a pair of 2. And that's going to come outside the square root symbol. That becomes that. And I'm left with 2 and times 5 on the inside. I'll just multiply those back together and I get 10. So the value of A is 2 square root of 10, not leg. Number 9, in the figure below, C is a transversal cutting through parallel lines, L and M. So the key thing here is that we know that these lines, L and M, are parallel. So we could put a parallel symbol on these if we wanted to. It says list at least four geometric relationships that exist amongst angles 4, 5, and 8. So let's just look at 4 and 5. What kind of angles are those? Well, we know that 4 and 5 from Unit 1 are alternate interior angles. And because line L and line M are parallel, we can say that those alternate interior angles are congruent. a second geometric relationship. Now let's look at 5 and 8. You can see that 5 and 8 are linear pairs, so we can say that they're supplementary. And lastly, because 4 and 5 are congruent, instead of saying that 5 and 8 are supplementary, I could also say that 4 and 8 are supplementary by the transitive property. Because measure of angle 4 is the same thing as measure of angle 5, so I can replace the 4 and the 5. So I can say those are supplementary as well. Well, I hope this gave you a little, this will give you a little help as to what you'll see in Unit 3 and a little review from the previous units. Again, if you have questions over simplifying square roots, please reach out to one of us. We have tutorials in the afternoon to help you go over into that, especially if you missed it in Algebra 1 with the whole schooling at home thing. If y'all don't have any questions, then we are done for today.